Students, welcome to the chemistry class. This session we discuss the entrance class one word question. Okay, in unit 4 transition elements topic. Now see the first question. Copper sulphate dissolves in excess potassium cyanide. Copper sulphate dissolves in excess condition potassium cyanide to give what is the product. Okay, so first this question, if you answer it, mean you know the reactions, chemical reactions. Okay, here conditions also it is given excess potassium cyanide. So now write the reaction copper sulphate plus potassium cyanide to give K2SO4 plus CuCN twice. Okay, again CuCN twice cupric cyanide to gives Cu2Cn twice cuprous cyanide plus cyanogen Cn twice Cu2Cn twice with excess, here condition excess potassium cyanide KCN to gives K3CuCN 4 times. That's all. This is the product. Okay, children. But here the product is never like that. But here it is in ionic formation. You studied in the coordination chemistry lesson. You know how to split. Okay. This is the final product. Potassium cuprocyanide. So now this one it is split into cation and anion potassium K plus 3 times. This compound that CuCN4 3 minus, because how many positive charges? Same negative charges it released. So what is the correct answer? Third option. Option 3, this is the correct. CuCN4 3 minus. But at the same time 2 minus also it is given. But according to the equation, which one is the correct one? Third option is the correct one. Here ionic stage, that is 3 minus. So copper sulphate dissolves in excess potassium cyanide to use CuCN4 3 minus. See the second question. Which one of the following characteristic of transition metal is associated with their catalytic activity? Children, we studied the theory part. Transition metal, it acts as the catalyst. Okay, the best example, Haber process. Okay, we know very well Haber process, preparation of ammonia, NH3 it is prepared. From the lower class onwards is studied repeatedly. Ammonia it is prepared from nitrogen and hydrogen. The catalyst is, what is the catalyst? Iron, it acts as the catalyst. Iron is the transition metal. Okay, we know very well the transition metals: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, so now this transition metal, this one for 3D series. The same way for 4D series and 5D series. So transition metal, it acts as the catalyst. They are asking the reason why. So this transition metal, each transition metal, it exists more than one oxidation state. Okay, even for example, if you take the manganese, the oxidation state plus 2, okay, 2 plus 7. Okay, so more than one element has more than one oxidation state. But at the same time, if we take the example as alkali metal, only one oxidation state. Alkaline earth metal, one oxidation state. But in transition metal, it exists variety of oxidation state. Okay, so due to their oxidation state, this compound or this element, it reacts with the reactant to give the intermediate product. After the intermediate product, that we know that to give the final product. Okay, so to give intermediate product. And next one, to give the interstitial compound. Okay, so in the solid state lessons we studied the topic interstitial. So interstitial means it is not present the particular place, it near it present. Okay, interstitial, it related to intermediate, in between. Okay, interstitial compounds. So it is capable of forming interstitial compound which can absorb and activate the reacting species. Such a character has the transition element. So this transition metal, it acts as the catalytic property. This is the reason. So studied in the theory part also. Now here give the 4 options. So now see the which one is relevant to the question. Question point, this option A, high enthalpy of atomization, paramagnetic behavior, color of hydrated ion, and variable oxidation state. So from this idea, now we give some points. Okay, so now we come to the conclusion. Catalytic activity due to the variable oxidation state. So the correct statement is variable oxidation state. So due to the variable oxidation state, it acts as the catalytic behavior. Next question. Among the following transition metal ion, the one where all the metal ions have 3D2 configuration. Here gives some series. So all the series as transition metal ions. Here are the charges. So we say transition metal ion. The particular series has 3D2 configuration. Okay, so 3D2 configuration. So now to find out which series is the 3D2 configuration. Okay, so here how that is easily to solve the question. See here first row titanium is given. Second one vanadium, chromium, manganese. So first we see the titanium. Titanium atomic number Z is equal to 22. Okay, so 3D2 4s2. This is electronic configuration titanium. Now see the option titanium plus. So one electron it is lost. So 3D2 4s1. Okay, but question is 3D2. So this option is wrong. Titanium 1. This one wrong. Next see the titanium 2 plus. Titanium plus 2. So plus 2 will lost this 2 electrons. So remaining 3D2. Okay, so now we find whether 3 or 4th option is correct because both also 2 plus 2 plus. Now check the titanium 3 plus also. Titanium 3 plus. 3 plus means 3D1 configuration. Are you clear, children? Okay. So now we come, that is 2 option is that is rejected. Okay, only 2 we have. Next see the vanadium. Vanadium atomic number is at atomic number 23. Okay, so here option vanadium plus 2 plus 3. Now want to see only 3 plus or 4 plus. Okay, so now 23. So 3D3 4s2. Okay, so vanadium 4 plus. What about the oxide? 4 plus means here 2, here 2. So remaining 3. So 3D3 configuration. Now take the vanadium 3 plus. 3 plus means 2, 1, 3. So remaining 2. So 3D2 configuration. So vanadium plus 3. So which one is the correct option? Now 3 is wrong. So 4th one is the correct one. So same way for check the remaining element also. Okay, manganese atomic number 25. So 3D5 4s2. So 3 plus 5. So only 3D2. Same way for chromium also. So what is the correct option? Option 4th one. Question is transition metal ion which series has 3D2 configuration. So this is the way to find out the answer. Question. Identify. The alloy containing a non-metal has a constituent in it. Alloy. Alloy, you know the definition. It contains more than metal as well as non-metal. Okay, so some composition. Some alloys contain non-metal, some alloy contain only the metal. It is made up of metal. Okay, so here question, alloy containing non-metal. Here some option given, bell metal, bronze, invar and steel. Okay, so now we know the composition of particular alloys. So bell metal, it contains copper 75 to 90%, tin 10 to 25%. Bell metal copper 78%, tin 22%. Invar nickel 36%, iron 64%. Steel chromium 11 to 13%, iron 73%, nickel 8%, carbon 0.1 to 0.4%. See the question, non-metal. Carbon is a non-metal. Okay, so which alloy? Steel. So now the correct option is steel. Steel contains non-metal. Non-metal as carbon. The percentage 0.1 to 0.4%. Next question. Which of the following does not, this is a negative type of question, does not react with AgCl, does not react with silver chloride. Here 4 options given, sodium nitrate, sodium carbonate, sodium thiosulphate, ammonium hydroxide. Children, now here AgCl react with the Na2CO3. Now give the product. You know the product NaCl. Okay. So first to get the product Ag, NaCl in the reactant side CO3. So it gives CO2 plus O2. Okay. So next AgCl plus sodium thiosulphate. So the product is NaCl. And next product is Na2 Ag S2 O3 twice, complex compound. Okay, so next one, here it react with ammonium hydroxide to give the product. So what is the product? Again here OH hydroxide group, so water molecule H2O. Okay, so next one Ag NH3, okay, twice Cl. So this also complex compound it produced. Okay, Ag NH3 twice Cl plus water molecule. But it does not react with the sodium nitrate. It reacts with Na2CO3, Na2S2O3, it reacts with ammonium hydroxide and to give the respective product. But it does not react with NaNO3. Okay, so why it does not react with NaNO3 means the sodium nitrate is a purely ionic compound. The silver chloride is the covalent compound. So this is the reason. So it does not react with NaNO3, but at the same time it reacts with silver nitrate, it reacts with the sodium chloride to get the product silver chloride and sodium nitrate AgCl plus NaNO3 to give the product. Next question, zinc gives hydrogen gas with H2SO4 and HCl, okay, but not HNO3 because now you can understand the question. Zinc react with hydrochloric acid as well as H2SO4. We know the product. What is the product? Zinc chloride ZnCl2 plus H2 gas liberated. Here ZnSO4 plus H2 liberated, H2 gas liberated. But at the same time zinc HNO3 does not liberate H2. Why? This is the question, because they are asking the reason. Okay children, here some that option is given. NO2 is reduced in preference to H3O minus and HNO3 is weaker acid than H2SO4 and HCl. Zinc acts as a oxidizing agent when react with HNO3. In electrochemical series, zinc is placed above the hydrogen. So now relevant option is given. Now we studied in the theory part children, zinc react with the nitric acid in very dilute condition. Okay, so now I writing the reaction. Zinc, it react with HNO3. Okay, but at the same time does not produce H2 gas, only it give the water molecule. Very dilute condition. Okay, very dilute. So now the product is ZnNO3 zinc nitrate plus NH4NO3. Okay, plus water molecule H2O, NH4NO3. Not here they give the option NO2 is reduced to H3O minus. Okay children, so now at the same time another one it reaction also it is possible. Zinc react with the dilute condition, dilute, to gives the product is ZnNO3 twice plus N2O plus water molecule. Children, now for this session I did it balanced. Okay, if I balance mean take again some more time, but here it is not necessary. So just write only the product, children. Okay, so here the product is N2O, here NH4NO3. At the same time it gives the water molecule, not H2. Okay, so now the relevant from this we come to the conclusion. HNO3 is weaker acid than H2SO4 and HCl. So the correct option for the particular question is option 2. HNO3 is a weaker acid than H2SO4 and HCl. And here also one option is given, electrochemical series. Zinc is placed above the hydrogen. If above the hydrogen it is present, mean it cannot reduce, it cannot give H2 gas. Okay, you know very well, concept you know very well, but actually the zinc is present below the hydrogen. Now I show it. Then see this tabular column is a photochemical series. Okay, electrochemical series. Above, zinc is placed above the hydrogen, the option is given. Now you know, can understand the meaning. This is a photochemical series, okay, or electrochemical series. Here zinc, sorry, hydrogen, okay, H2 above and below. Okay, so above, what are the element it present? It should not release H2 gas. For example, if you take copper, it does not give H2 gas. Okay, if react with copper plus HCl to use copper chloride plus H2, the reaction does not take place in the presence of water molecule to give the respective product. But here zinc is present below the hydrogen. Can you understand the concept, children? Okay. Let's see the next question. For making Ag silver, for making Ag from AgNO3, which of the following is used? Here they are asking the catalyst. Okay children, so Ag is obtained from AgNO3. So AgNO3 to gives Ag and NO3 to gives NO2 plus O2. So here use the catalyst as PH3. PH3 is phosphine. Okay children, so for this reaction what are the catalysts used? Here the relevant catalyst is phosphine, PH3. So what is the correct option? PH3 phosphine. Okay, this one arsenic hydrate, sodium carbonate, ammonia. So the correct option is phosphine. Now phosphine alone to give silver nitrate to silver nitrogen dioxide and oxygen. The next question, among the following the compound that both paramagnetic and colored. Okay, so first we know the meaning for paramagnetic. Paramagnetic means the metal has unpaired electron. Okay, unpaired, if even a single unpaired electron it is present, the compound we called as paramagnetic in nature. For example, d orbital. Okay, 5, 1, 2, 3, 4, 5. So 2, 3. If any one electron, maybe it is present, the unpaired electron, the compound is paramagnetic. If paramagnetic means the substance it has colored. Okay, so absence of electron or completely filled d orbital. Now the compound is colorless. That is D0. or D10 configuration, the element is colorless, that denoted as absence of electron, or completely filled, the substance is colorless. At the same time, if contain a single electron, it is color. So from this question, now to find out the configuration, D configuration. See the first option, K2Cr2O7. Okay. So now to split the compound Cr2O7 2 minus. You know how to split. Okay. So now here this is the transition metal. Now to find out the configuration or oxidation state, 7 oxygen plus 7 into minus 2. Okay, here minus 2. So now to find out, same way for here NH4 twice. So NH4 plus, so 2. Okay, and next one this titanium, so X. Next chlorine 6 times, so 6 into minus 1 equal to 0. See, take the third option, vanadium. Okay, so this one third, this one for first, second. So V taken as X, oxygen minus 2, and here the whole term SO4 minus 2 equal to 0. And next this fourth one, here also to split. Okay, plus as well as minus. So potassium plus, this one minus, 3 plus 3 minus. So now write the fourth one here. So Cu consider as X, cyanide plus 4 minus 1. So 4 into minus 1 equal to here minus 3. Okay, children. Now see the calculation. Cr2O7 2 minus X is equal to 6. So chromium plus 6 oxidation state. Chromium atomic number 24, 3D4, 4s2. So in plus 6 means 3D0 plus 6 electron last. So 4 plus 2, 6 electron, it is last. So 3D0 configuration, it is diamagnetic in nature. Okay. So see the second one, NH4 twice TiCl4. Here plus 4 oxidation state. Here the metal is titanium, Ti. So Ti4 plus, titanium atomic number 22, 3D2, 4s2, 4 plus, so 2 and 2, 4 electron is last, 3D0. This also it is a diamagnetic in nature. Third option, VOSO4, V, vanadium. Okay, so now here 3D vanadium plus 4, so 3D1 configuration. Vanadium atomic number 23, the 3D3, 4s2, here plus 4, so 2 and 2, 4 electron it is last, so remaining 1. It is a paramagnetic in nature. Paramagnetic. Okay, so this one diamagnetic, this also diamagnetic. Okay, next see here. Fourth option, K3CuCN4. Here copper metal. Copper plus 3D10. Copper atomic number 29. Okay, so electronic configuration 3D10, 4s1 plus, so 1 electron it is lost. So 3D10, this one also it is diamagnetic, but the question they are asking paramagnetic. So this only paramagnetic. So the correct option VOSO4. Next question, a reduction in atomic size with increased atomic number is a characteristic element of, here give the option. First one, high atomic mass. Next D block. Next F block. Next option, both D as well as F block. Children, we know the concept. The size decreases. When the sizes decreases means increase the atomic number in D as well as F. Okay. So in F block we studied the lanthanide contraction. So in M, that is M3 plus ion, the size decreases with increase in atomic number, children. Okay, we know the concept. So here the correct option is both D block as well as F block. Because the size decreases. When the atomic number is increases one by one, the size decreases. So it's in D as well as F block. So correct option is fourth one, second, D as well as F block. The next question, the outer electronic configuration of GD, gadolinium, atomic number 64 is. They are asking the electronic configuration. Okay, so this gadolinium element, it is present in the lanthanide series. We know the general electronic configuration, xenon. Okay, so next 4F 1 to 14, 5D1, 6S2. Here atomic number 64 is given. Xenon atomic number 54. Okay, so xenon 54. Next, to fill the electron, 5D1, 6S2. Okay, so here 54, 55, 57. So totally 57. So remaining 7. So 4F7. So this is the way to fill the electronic configuration of xenon, of the element. Okay, so now, keep in mind the general electronic configuration and fill the electronic configuration. Okay, so now see the correct option. Okay, here 4S7, 5D1, 6S2. Remaining here 8, 4, 3 are given. So now correct one is 4S7, 5D1, 6S2. Okay, 6S2, 5D1, 4F7. So correct answer this one. The next question, the cation. Cation, you know very well, positive charge with that will not precipitate by H2S in the presence of HClS. Okay, so hydrochloric acid, H2S. Now to get the precipitate, but here the question is will not precipitate by H2S in hydrochloric acid, that is acidic medium, hydrochloric acid. Okay, denoted as the acidic solution or acidic medium. Now here some option is given: Bb lead +2, As arsenic +3, cobalt +2 and copper 2+. Children, we know the concept in acidic medium, lead, arsenic and copper give the precipitate, children. So this alone, cobalt alone, it should not give the precipitate in acidic medium. But in alkaline medium, that is ammoniacal solution, in alkaline medium, it give the precipitate. Are you clear, children? This one, Bb, As and Ca2 plus give the precipitate in acidic medium. CO, it does not give the precipitate in acidic medium, but it give the precipitate in ammoniacal solution. So the correct option is CO2 plus. Children, next question, if N is equal to 6, the correct sequence for filling electron, correct sequence they are asking. Children, now in 11th standard we studied the periodic classification lesson, children. In periodic classification, the first period contain how many elements? 2. Second period 8. Third period 8. Okay. Fourth period 18. Fifth period 18. Sixth period 32. And 7th period 32, but incomplete. Okay, so in first period 2 element it present, it is explained based on this electron. So 1s, n is equal to 1. So 1s orbital, here 2 electron. Here n equal to 2. Okay, here n is equal to 3. Here how many electron? p orbital 6, s orbital 2. So totally 8. Okay, so here 8 element it is present. See here S2, D10, here P6. So totally 18. Here 6th and 7s. Here 32 element it is present. Children, you can remember the series is easy way. So I give the point here. Okay, this one studied in 11th standard. Okay, so first period only 2 element it is present. So this 2 element it present, it explained based on this configuration. Okay, so n is equal to 1, 2 electron. N is equal to 2. Here 8, 6 plus 2, 8 electron. So 8 element it is present. N is equal to 3, 8 electron. So 8 element it is present. So based on this they are construct the periodic table. So now an easiest way to remember the electronic configuration. First 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d and 5p. Next 6s, 4f, 5d, 6p. Okay, so next is 7s, 5f, 6d and 7p. So this alone have studied in the half-half principle, Pauli exclusion principle, Hansrud. Okay, half-half principle, the electrons are arranged in increasing order. So and next one, this one is explained based on the n plus L rule. Everything is studied in 11th standard. Okay, just a recall. So based on n plus L rule. Now come to the point n equal to 6. So now n is equal to 1, n is equal to 2, n is equal to 3, here n is equal to 4, n equal to 5, here n equal to 6. Now they are asking this series, n is equal to 6. So 6 is 4f, 5d and 6p. Now n value 6. So see here, first which one? N is. Okay, next f orbital. Where is the f orbital? This option as well as this option. Only f orbital. So remaining just leave it. 1 as well as 3 is wrong. Okay, because next after the 6 is f. So n minus 2f. Here n minus 2f. Here also n minus 2f. Okay, children. So next 5d. So 5d mean here n value 6. So 6 minus 1, 5. 5d. So correct option. Second one is the correct option. Very clear, children? Can you understand this question? I hope you can understand because I studied in previous class also. Okay, so n is equal to 6. This order 6 is 4f, 5d and 6p. Now here mentioning ns. N denoted as 6. So here 6s. Next 4f, 5d and 6p. Each of the element with the following outer orbital configuration may exhibit largest number of oxidation state. Okay, children, once again, which of the element with the following outer orbital configuration, here giving the outer orbital configuration, exhibit largest number of oxidation state. Now 3d2 4s2. So 3d2 4s2 means now the atomic number titanium, that is 22. Okay, titanium atomic number Z is equal to 22. So 3d2 4s2. 3d2 4s2. And next one 3d3 4s2. Vanadium atomic number 23. Electronic configuration 3d3 4s2. Here 3d5 4s1 is given. Okay, children. So this one for wrong. Okay, so look, pattern it is wrong. So next one 3d5 4s2. Manganese atomic number 25. Electronic configuration 3d5 4s2. So now to identify, first one element is titanium, second one element is vanadium, this one for manganese. So now we know the titanium, here they are asking the largest number of oxidation state. So titanium oxidation state +2 to +4. Titanium oxidation state +2 to +4. Next vanadium oxidation state +2 to +5. Manganese oxidation state +2 to +7. So this is the largest number of oxidation state. So correct option is the fourth one 3d5 4s2. So this is the correct answer. Okay. See the question, which is the correct order of increasing energy of listed orbital in the atom of titanium? Increasing energy of orbital, okay, in the atom of titanium. First write titanium atomic number. Titanium atomic number 22. Okay, so write the electronic configuration 1s2, 2s2, 2p6, so totally 10. Okay, next 3s2, 3p6, next 4s, next 3d. Okay, but actually we are writing 3d and next 4s. Okay, so this alone we are writing 3d and 4s. Here 8 electron, remaining 2, so here as well as here 2, 2, so 22 it is balanced. Here 10, okay, so 22. Now they are asking increasing energy. Okay, so because this one is complicated for this area, somewhere we are writing 3d and 4s, and next one 4s and 3d. So two option. So which one it is correct? Okay, so which one it is correct? Correct mean now it find out from the based on n plus L rule. Are you clear, children? Okay, so now what is n plus L rule? So now I am writing 3s, 3p, 3d and 4s. 4 orbitals I am writing here because this area alone we are just doubt. Okay, so 3s, 3p, 3d and 4s. Now write the n value. N is the principal quantum number. So the first number want to write here 3. 3, here 3, here 4. Okay, so write. Next L value. L value 0, 1, 2, 3. L value 0, S orbital, 1, P, D and F orbital. This one repeatedly studying in 11th standard. Okay, so now here S orbital. So S orbital means 0. P orbital 1, D orbital 2, F. Now, okay, so S orbital 0. Now add this to 3 plus 0, here 3. 3 plus 1, 4. 3 plus 2, 5. Next 4 plus 0, 4. So now write in the order. First want to write 3 number. Fourth. And here also 4. Both also same. Okay, so here both also 4. Here also 4. Both also same. Now want to see the principal quantum number. Here number 3, here number 4. So which one is the lowest n value? Write first. So the 3 and 4. So this is the lowest value. So write first. Are you clear, children? So next want to write 3D. So now writing the order. Here first which one want to write? 3. So 3 yes. Okay. So next 3P. Okay. So next which one want to write? 4S. Last one number 5 want to write 3D. So this is the way to find out the correct increasing order. Now see the option 3S 3P. Where 3S 3P? Here 3S 3P. Next 4S and 3D. So this is the correct answer for titanium out electronic configuration in increasing order. Okay, so not 3D, 4S, 4S and 3D because it is based on N plus L rule. Final question, the electronic configuration of chromium is, okay, chromium is a transition element. Chromium atomic number, chromium symbol Cr, okay, chromium atomic number 24. Electronic configuration 3D4, 4s2. Okay, so due to symmetry, now write the electronic configuration 3d5, 4s, 1 electron it is shifted. Okay, so due to symmetry. Okay, so now 3d5, 4s1. So here correct option 3d5, 4s1. This is a chromium electronic configuration. Children, I hope you understand this session. Thank you.